Hi there. So welcome back to another video. So I got a comment on TikTok to solve this indefinite integral, but I was given the restriction to solve by using partial fraction decomposition. From this indefinite integral, we can't actually solve this by using U substitution, but I was given the restriction to solve it with another method, the partial fraction decomposition. So this is actually not that bad of an integral to solve. What a lot of common mistakes when you're learning partial fraction decomposition, especially when you're dealing with integrals, when you're solving for those numerators, is you need to keep in mind with the exponent, the terms of the multiplicity, and what kind of functions that you use to actually help solve for your coefficients. So for example, specifically, if I had something in the denominator in terms of a quadratic function, so for example, let's say x squared plus 1 on the denominator, and if we're solving those terms of coefficients, whatever is on the numerator has to be in terms of a linear function, so some constant. I'll say a times x plus b, but if it's just a linear function, then it's in terms of just a regular constant itself. But here we're dealing with multiplicity, so you have to keep in mind how many there is, so you have to keep it to the amount that what was given. But you'll see where I'm coming from this. This is actually more of a general example on how to solve with partial fraction decompositions with, in terms of solving these integrals. So other than that, let's actually just jump right in and just get this out of the way. For this integrand, x divided by x minus 5 and then x minus 6 quantity square. So we can actually break this up into 3 different terms. So for one, a and then divided by, so our first one we have is x minus 5, and then add this with b. Then we have that, and it's also worth noting that inside the quantity is a linear function, so it's just having to deal with just the coefficient itself. Say something that if we had some sort of quadratic function and then with however many of the multiplicity numbers there is, so of course you have to follow with those guidelines on what functions you need to choose in order to keep the numerators and then solving for those coefficients. But since everything in terms of the linear function, so the numerators, everything is just in terms of constants. Now we have x minus 6, but because we have doubled that, so we have to keep that a second time. So it's c and then x minus 6, then quantity square. So keeping in however many times. So there was, for example, I'd say if there was 3, so x minus 6 quantity to the cube. So you have to do this 3 different times. So x minus 6, then x minus quantity square, and another one for x minus 6 quantity cube. So these are just some guidelines that you want to at least pay attention to that and make sure you don't get this mixed up and make those common mistakes, because that really tends to happen, especially when you're doing these kinds of stuff, especially in integral calculus. From here, let's actually put everything into the common denominator, but that means I have to multiply everything from the denominator back into these coefficients over here. So by applying that, so I have that a, and then we put this as x minus 6 quantity square, add this b. So we have x minus 6, then do this again, and then x minus 5. So x minus 5 times x minus 6, and then plus c, then multiply with x minus 5. And then when you're solving these partial fractions, you set everything, then set this equal to the numerator that you're trying to achieve for x. So set this equal to x. Then what I can do here, let's actually expand everything out. So I have now a, then this is using the FOIL, so x squared minus 12x, and then add this with 36. Then over here now plus b, this is going to be equal to x squared, then minus 11x, and add this with 30, then add this with c, then times x minus 5, and just keep it the way it is, x. Then if I just distribute everything for the coefficients of a, b, and c into here, so we'll have ax squared, then minus 12 times a times x plus 36a, add this with bx squared, then minus 11b times x, add this with 30b. Then now we're going to distribute the c, so plus cx, and then subtract by times c, and then equals x. Okay, and so from here, what we want to do, generally, if you're solving with these partial fractions decomposition, for the easier ones specifically, that we didn't have to do this all expansion, what you can do is you can plug in whatever the roots are for these, linear functions over here, so 6, 5, but there's, because we have more with that, and there's also the multiplicity with square, or number 2, so there's a little more that we have to, further investigate in reaching and solving for. So with this, another approach we can do from solving these unknown coefficients is you set this in a sense of a systems of equations. So what we'll do here is we'll match everything with term by term and then set that equal to the right-hand side term by term. So let's start off with the x squared. So we have the ax squared and bx squared. So if I put this together, so I have a plus b, then let me just put a mark so that it actually cancels that term. There's nothing for the x squared quantity. There's nothing for like the quantity in terms for the x squared. So that means this is going to set that equal to 0. And then the next one we have is in terms of x. So I have a negative 12a. So that's out. And then we have a minus 11b and then minus 5c. And so there is an x, but that's just only 1. So set that equal to 1. And then now we're just dealing with just the constants itself. So this is out of the way, this is out of the way. And so now this is going to be 36a, and then add this with 30b, and then subtract 5c. And so this is no constants on the right-hand side, so that's just equal to 0, so that's fine. Okay, so this is systems of equations. Now we just have to solve for each of these unknown constants. Not so bad. So for when we can actually start with a little bit something easier, we have an a plus b is equal to 0. So let's actually subtract a b, and so I have that now. For now, we have that a is equal to negative b. So now we just plug in everything for a to these two equations and set that to minus b. Easier way to do this is, the easier one we're going to start with is the one that's set to equal to 0. At least we can actually get some sort of, it makes our work a little bit easier, in other words. So plugging this back in, so I have now, this is going to be, so now we're going to have negative 36b, add this with 30b, and then subtract 5c, is going to equal 0. Okay, so if I just combine this all together, so I have negative 6b, and then just add the 5c to both sides. And then we also want to put something in terms of c as well, so just divide both sides by 5. And so far we'll have the c is equal to negative 6b divided by 5. So everything's good so far, so that way we have everything for now. The second equation is left. So now putting all this back in, so we'll have everything in terms of b. So now putting this back, so we have 12b, and then now subtract 11b, then plug in the c that we said this is negative 6b, and then 5. That's actually supposed to be just a c over here, plus c. And so now this is going to be minus 6b, then divided by 5, and then this is going to set that equal to just 1. That if we actually solve all this out, that means I have just b, and then minus 6b divided by 5 equals 1. In other words, that's another way to set this as negative b divided by 5 equals 1. And then now just b is just going to just equal negative 5 from here. And so we just plug this back in, plug back negative 5 back to here. So that means I have that a is equal to 5. And then we just plug in back here and get our c coefficient. And then that's pretty much just going to straight up just give us 6. And so we have all our a, b, c coefficients found. And then we just plug this back into over here. So now yielding us, this is going to be so far the integral from x divided by x minus 5, and then x minus 6 squared, then dx, and then applying all that linearity. So we have 3 different integrals to solve for. So this is going to be the integral from 5 divided by x minus 5 dx, then subtract 5 divided by x minus 6 dx, and then now add this with the integral of 6 divided by x minus 6 quantity squared, and then dx. Everything is pretty much easy to solve for here. This is actually just apply to use substitution. So what we have now is that this is actually going to come down to 5 times ln, and I'll just put in an absolute value just to denote the positive. The natural log of x minus 5, then subtract 5 times the ln of x minus 6, and then applying u sub over here, and then after all that, we're going to get that this is subtract 6 divided by x minus 6. And because this is an indefinite integral, make sure you put in your plus c constant, because we don't know where we're integrating from in terms of the finite integral. And so with that, that actually just completes our final solution for finding this indefinite integral, specifically for applying partial fractions. So if you have anything you want to add in terms of problems for me to solve, then feel free to leave that in the comments. Can't guarantee that I'll be able to solve or put in a video, because I'm not that gifted. I'm not exactly a genius, but I do love solving these things in the form of an attempt. But feel free to do so, and if by luck, hopefully your problem may end up in a video of mine. So yeah, that's pretty cool if you ask me.